Light is extremely fast, even the fastest thing humans have ever known. According to the laws of physics, nothing can surpass the speed of light. It travels at a speed of nearly 300,000 kilometers per second and takes just under 1.3 seconds to go from the Moon to Earth. The average distance from the Moon to Earth is 384,403 kilometers, a crucial figure in humanity's journey to conquer the Moon. 9 crews have flown to the Moon, including the Apollo 8, Apollo 10, Apollo 13 missions, and 6 lunar landing missions. It took them over 78 hours, equivalent to 3 days and 6 hours, to reach lunar orbit. Apollo 8 completed the fastest journey, taking only 2 days, 21 hours, and 8 minutes. In contrast, Apollo 17 was the longest flight with a total duration of 3 days, 14 hours, and 41 minutes, including Earth orbit time. Even just 1% of the speed of any object might sound insignificant, but for light, that figure is truly enormous, reaching nearly 11 million kilometers per hour. At this speed, it would take us just over a second to travel from Los Angeles to New York, a distance of 3,940 kilometers, which is 10,000 times faster than today's commercial jetliners. So what are the fastest things humans have ever made? The bullet can travel at speeds of up to 4,200 kilometers per hour, more than 3 times the speed of sound. The fastest aircraft in the world today is NASA's X-3, a jet capable of reaching a maximum speed of up to 11,200 kilometers per hour. While this number sounds very impressive, it actually amounts to just 0.001% the speed of light. The fastest man-made objects are spacecraft. They are launched by rockets to reach Earth's escape velocity, approximately 40,000 kilometers per hour. Currently, NASA's Parker Solar Probe holds the record for being the fastest moving spacecraft. Scorching atmosphere and utilized the star. That speed is mind-bogglingly fast, but in reality, it's only 0.05% the speed of light. Why is even reaching 1% the speed of light such a huge challenge? What barriers are preventing humanity from hitting this milestone? In short, that is energy. Any object in motion carries energy due to its movement. Physicists call this type of energy kinetic energy. To go faster, you need to increase kinetic energy. But the problem is that it takes a tremendous amount of kinetic energy to accelerate. This means that to double the speed, you need 4 times the energy. To triple it, you need 9 times the energy, and so on. For example, to accelerate a 50 kilograms teenager to 1% the speed of light, approximately 200 trillion units of energy would be required, equivalent to the amount of energy consumed by 2 million Americans in a single day. What's the maximum speed we can reach? Thus, to accelerate an object to 1% the speed of light, we need an enormous amount of energy. Can humans make an object move even faster? Perhaps, but engineers need to develop new methods to help objects move through space more efficiently. All types of rockets, including the latest models developed by SpaceX and Blue Origin, operate on the principle of fuel combustion, essentially not much different from the fuel combustion process in car engines. The issue lies in the fact that this fuel combustion efficiency is too low. There are far more efficient methods than using chemical fuel to propel spacecraft, such as utilizing electric or magnetic forces. Additionally, nuclear fusion is the very process that powers the sun. With electromagnetic force, we have electric motors. Ion thrusters not only increase speed but are also more efficient than chemical engines when considering the same fuel mass and equivalent travel distance. As a result, the new engine consumes less fuel while still transporting larger cargo loads and carrying more astronauts into space. Compared to chemical rockets, ion engines have relatively modest thrust. This means the system must operate continuously for a very long time to achieve acceleration equivalent to that of chemical propulsion. Therefore, it is not suitable to start the engine and take off. The good news is that spacecraft powered by nuclear fusion energy may soon become a reality, no longer just a sci-fi dream. And this is the D-Refuse and Drive engine, abbreviated as DFD, which is expected to undergo its first test in 2028. If successful, the spacecraft equipped with the DFD fusion-powered engine could take humans to Saturn in just 2 years or to Pluto in about 5 years after launch. Cassini spacecraft, which took only 6.75 years to reach Saturn, the agency. The dual-boost engine operates as a powerful energy source, meaning this technology can be widely applied beyond space. For example, The DFD could power the planned Lunar Orbiting Gateway space station under NASA's program, as well as bases on the Moon and Mars. Inside the DFD contains a type of hot magnetic plasma, consisting of helium-3 and deuterium, a unique isotope of heavy hydrogen with one neutron in its nucleus, differing from ordinary hydrogen which contains no neutrons. The atoms of these elements will combine in a plasma state, releasing a large amount of energy while producing very little harmful radiation. The molten plasma heats the filler material outside the containment chamber. The filler is then directed to the engine's rear nozzle, generating thrust. Theoretically, nuclear fusion is extremely difficult to harness. To date, no one has succeeded in building a fully scalable and commercially viable fusion reactor. However, this energy source is still considered a solution for the future. Additionally, scientists are actively researching other methods to travel at higher speeds, including the World Drive, a faster-than-light propulsion technology in the sci-fi series Star Trek. The spacecraft is equipped with a vertical warp drive, capable of traveling at speeds many times faster than light. Unlike some fictional faster-than-light technologies such as jump drives, a warp drive cannot instantly move from one point to another, and pertaining to a measurable period of time, consistent with this concept. Unlike hyperspace, a spacecraft moving at subluminal speed will still interact with objects in normal space. To date, the achievements researchers have made are still limited to theoretical experiments. Physicists need to continue deeper research so that hypotheses can more accurately reflect reality. However, we still hope that the research will soon succeed in practice, turning humanity's dream of conquering space into reality in the not-too-distant future. Another promising method to accelerate an object's movement is by using solar sails. The spacecraft will be equipped with large, thin plastic sheets, allowing sunlight to exert thrust on them, similar to how wind pushes against a conventional sail. Scientists believe that solar sails could enable spacecraft to reach 10% the speed of light. Sail technology has been used in space before, most recently in the Planetary Society's LightSail 2 mission, which has been operating in orbit for 2 years. Although solar sail technology is still in its early stages, its potential benefits are immense, including the ability to extend mission duration by overcoming the limitations of available fuel compared to chemical or electric propulsion systems. The mission managers will also evaluate the performance of the spacecraft's propulsion system during orbital adjustments, in preparation for future missions exploring beyond Earth. Who knows, one day, when humanity is no longer constrained by the sluggish speed compared to light, we might be able to journey to the distant stars?